Today's video is on page 2 of your new Unit 1C packet, linear equations using slope and y-intercept. The graphs give information about a penguin's number of heartbeats, v, over time, t minutes, during normal resting and just before diving. When is the penguin's heart rate greater, during normal resting, which is on the left, or just before diving, which is on the right? To find each heart rate, key word there, find the unit rate for each graph. To find the unit rate, we remember when x equals 1, from our 7th grade material, remember y divided by x equals k. So when x equals 1, that gives us our unit rate. So when x is 1 before diving, the unit rate is 200 beats per minute. In the normal resting heart rate, when x equals 1, it's about 75. And yes, I could check that because 150 divided by 2, y over x, y over the x, is 75. This is 75 beats per minute. And the way I could also do it is to do this little math ratio here, which says the rise over the run. How the line rises, going up or down the y-axis, because it could fall, over how it runs across the x-axis. So it's going up 150 and going over 2, which also gives me that 75 beats per minute. In the example on the right, the normal resting heart rate, my rise, it's going up 200 and over 1 minute. Up and over. So rise over run. So y over x. Y over x. That's also going to give me that 200. Because the graphs have different scales on their vertical axes, you may not be able to tell just by looking at the slope that one's greater than the other. You really need to calculate the slopes of the line to see which is greater. And you need to pay attention to the scale. This is counting by hundreds. This is only counting by 50s. The graphs give information about the distance d, miles traveled over time, t, hours, by cars and trucks on a California highway. Which speed is slower? So I'm going to do my rise over run, which is called the slope. In the first graph here, I'm rising 100 and I'm running 1.5. This is 1.5. So 100 over 1.5. Well, that would be, I'm going to slide that over. That's going to be 1,000 divided by 15. Is not a nice number. That's 66 and 1/6. Oh no, 2/3. 66 and 2/3, or 66.66666666666 miles per hour. That's the rate. We're finding a rate, the constant rate. These are also proportional relationships, as we remember, because they're going through the axis and it's a straight line. So there's a constant rate here. In the example on the right, the speed for the trucks, letter D here, or speed for trucks, we're going on my rise over my run, going up 100 and over 2, well, that's only 50 miles per hour. So the cars are traveling at approximately, because your speedometer is not going to tell you 66 and 2/3 miles per hour. It's about 66 miles per hour, and the trucks are going at 50 miles per hour. So which speed is slower? Oh, or lower? It's the trucks. 50 miles per hour is slower than 66 2/3 miles per hour. Find the slope of each line. So the slope is the rise over the run. We're going up by 5 and going over by, ooh, be careful, 1, 2, 3, 4. So I can do it this way as well, or I can go up by 5 and over by 4. This slope is rise over run, and you can see that they're calculating it right here. So the rise is 5 units and the run is 4 units. Up 5 and over 4. The slope is 5/4. Here, in the graph on the right, letter B, the rise or the fall, because it's going downward, the fall is going down by 4. So down by 4 and over 1, 2, 3, 4. And over by 4. So we're not going to leave it -4 over 4. That would simplify to -4 over 4 would simplify to -1. And you can see at the bottom here, the graph passes through those 2 points. The rise over the run, I could use the points to figure it out, or just count on the graph paper. Yes, the y values are the rise, and the x values are the run. So this is the y's being subtracted over the x's being subtracted, and I get 5/4. I counted the graph paper at first, but I could use this formula of my y values being subtracted over my x values being subtracted. So the slope of the first graph, letter A, is 5/4. The slope of letter B is -1. A line graph has a positive slope if it goes up from left to right. Up from left to right. That's a positive slope. It's going up the graph paper. It has a negative slope if it goes down from left to right. So that's a negative slope. Number 2. The graph passes through these points. Okay, so I see the point -2, -1. That's this point. And the point 4, 3. That's this point. I'm finding 2 easy to read points exactly where the graph is crossing the axes here. And if I do my slope, which is my y values, and they say y sub 2 minus y sub 1, and over x sub 2 minus x sub 1, well, I write it as the Greek letter delta. Delta means difference. Difference means subtract. So I shortcut, because I don't want to keep writing y minus y and x minus x, and I don't want to put the little 2 and the 1 in. So I say delta y over delta x. Delta, the airline's delta, we are the different airline. We're different. We're better than everybody else. That's why they use the Greek letter delta. We're the different airline. It means difference. Delta means difference. So the difference in the y values. So if I do, and I could start and say 3 minus -1, 3 minus -1. So I'm using the formula here. I'm not looking at the graph. And 4 minus -2, be careful, 4 minus -2, we know that that's really 3 plus 1, which is 4, and 4 plus 2, which is 6. Well, we could simplify that to 2 over 3. Well, now I'm going to go up to the graph and I'm going to say, does it go up 2 and over 3 every time? So up 1, 2, and over 1, 2, 3. Hey, yes, it hit the point 1, 1. Up 1, 2, and over 1, 2, 3. So if I have graph paper, I do that. I use the graph paper and count my rise over my run. That way I don't have to do the formula delta y over delta x. But I'm going to do it both ways for example 3 here. So the graph passes through, the point -2, 4. and the point 2, negative 2. So my delta y over delta x is, and now I'm going to go this way. As long as I'm consistent, taking the first y value of 4 and subtracting the second y value, so I have to take the first x value, which is negative 2, and subtract the second x value. So I draw kind of arrows so I remember I'm consistent with it. Well, that equals, and I think I'm going to go off the screen here, 4 plus 2 is 6. And negative 2 and negative 2 makes negative 4. So this is 3 over negative 2, or going down 3, 1, 2, 3, and over 1, 2. Yes, it's falling 3 and running by 2. Falling 1, 2, 3, falling by 3 and running by 2. So the slope is negative 3/2. Find slopes of horizontal and vertical lines. Think about a horizontal line. Well, I know that this is the line y equals 2. We talked about that when we were doing intercepts. This whole line here is the line y equals 2. The run is positive. The rise is 0. So I'm not rising whatsoever at all. So the rise over the run formula here, you can see zeros in the numerator. That's okay. The run, well, I can go over 1, or I can go over 2, or I can go over 4. I can go over infinitely many times. My run just keeps going. So 0 over infinity, well, that just equals 0. That slope is a 0 slope. So that line has the slope of 0. Think about a vertical line graph, and we talked about this in class yesterday. X equals 1. For a vertical line, the horizontal run from one point to the next, well, if I start here at 1 and I go up to 2 or 3, that's going up by 2. Or if I go up infinitely many times, I have infinity for my rise. I can keep going, or I could keep falling. But my run, doesn't change. 1 minus 1, because this is where, right, x is 1, x is 1, x is 1, x is 1, because x equals 1. You get 0 in the denominator. No, no, no. So we call that, remember, undefined. That's a slope that is undefined. So you can have positive slope, negative slope, 0 slope, or what we call no slope or undefined slope. And we'll watch a funny video, Slope Man, about this. So 0 slope is the horizontal lines, y equals are 0 slopes. The vertical lines, x equals, they have undefined slope. So positive, negative, 0, undefined. On the next page, a vertical line, what is the slope? The slope is undefined. Yes, I could put points in and I could say, oh, here's the point 4, 3. And here's the point 3, 0. So when I do my delta y over delta x, changing the y values, 3 minus 0, well, that's 3. And my I did this wrong. That's not 4, 3. That's 3, 4, you goofball. See, we all make mistakes. So my y values, 4 minus 0, let's start over there. And my x values, 3 minus 3, I'm going to get a 0 here, and 4 minus 0 is 4. Can't do that, undefined. In my second example here, I have that horizontal line, so I know my slope is going to be 0, and yes, I can check it with my points, and hopefully I'll do it correctly. Oh, they put the points on there for me. So negative 2, 2, and 4, 2, delta y, the y values over delta x, and the oops is that you subtract the x's on the top. No, no, no. The y's, 2 minus 2, that would be 0 on the numerator. That's okay. And negative 2 minus 4, being consistent, I would get negative 6. Well, that just equals 0. So vertical lines have undefined slope. Horizontal lines have 0 slope. Next page. Understanding the slope formula. And here it is. There's that y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Teachers don't like saying that, so they just say rise over run. I'm a delta fan. Delta y over delta x. All of these things mean the same thing. Subtract the y values over subtracting the x values. That's the slope formula. So you can see an example here. When we go to compute it, here's my delta y over delta x. And you can go ahead and subtract it there. From the rise of point A to the rise of point B, it does not matter whether you subtract A from B or B from A or the other way around, as long as you are consistent, you do them in the same order. That's why I do that. Ooh, subtract the points this way or subtract the points that way. So the slope formula can be stated as follows. The slope of a line passing through 2 points x sub 1, y sub 1, and x sub 2, y sub 2 is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or y sub 1 minus y sub 2, you can do it in the other order, over x sub 1 minus x sub 2. Ugh, delta y over delta x, way easier, and that's what I write on my paper, delta y over delta x. Remember, caution, 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 always be consistent. Use the same order. Next page. Find the slope of the line passing through each of the following pairs of points. Oh, no graph. So, delta y over delta x, 0 minus 4, y values, negative 2 minus 0, would give me negative 4 over negative 2. Well, that's just 2. So number 6 has a slope of 2. Delta y over delta x. Number 7, I'm going to go the other way. 2 minus 8, y values on the top. Negative 2 minus 5. And I'm going to get 2 minus 8 is negative 6, and negative 2, take away negative 5. Ooh, be careful, I missed that. Mistakes. Negative 2 minus negative 5, that's positive 5. Negative 2 and positive 5 gives me positive 3. This slope is negative 2. When I simplify it. Be very careful. Don't try to squish your work here. Make sure that you're putting the negative and negative in. See, I almost made a mistake there. That's a common oops. Number 4, the graph represents the amount of water in pool A over time t and the amount of water W left in pool B over time t. Well, pool A is definitely the water is going up, so that must be filling. Right? Oh, it says that, filling pool A and draining pool B. Find the slope of the line graph for pool A. What does it represent? So the slope, delta y over delta x. So A is going up by, and I'm going to pick this point, and I'm going to use the graph paper. It's going up 180. I'm not going to use the slope formula. And it's going over 4. So what does that represent? It means that the water is increasing by 45 gallons per hour. It's a rate. It has two labels. 45 gallons per hour, the water is filling. That's what A is. What does it represent? 45 gallons per hour. So I'm putting the labels because this is graph paper and it has labels on it. These up here, I don't know what these points represent. I don't know. No labels. But here, because it is a rate and we have the labels, the two variables, the dependent and the independent. This is the dependent variable. This is the independent variable. So I'm going to use those labels. The draining pool, let's see, it's falling. I'm going to use this point and this point. It's falling by 150 over 4. Well, that's negative 37.5 gallons per hour. Use both labels. You have to give both labels there. So the slope is a rate. Delta y over delta x. Remember, last year it was y over x equals k. Well, now it's delta y over delta x, and the letter is a m. M is slope. For any constant in a proportional relationship, you can have a constant called k. But in a linear relationship, delta y over delta x is m. And we're going to talk more about that tomorrow.